So hello everyone, my name is Elian. Over the past year, I have been working on a passion of mine, climate change. I've been working on combating climate change using a super cool emergent technology called gene editing. And I'll be explaining all about that in this presentation. But first, I have a question for you. Do you think that this little green speck can solve the climate crisis? Hold on, let me zoom in a little bit. This is a microalgae, an organism so small we can't even see it with the naked eye. But this guy has the power to power our future for generations. Let me explain how. We all know that the world runs on energy. And you might know that 80% of the world's energy comes from fossil fuels. Fossil fuels, as we know, are really bad for the environment because they pollute our atmosphere full of carbon dioxide. But they're also extremely hard to get rid of because they're very energy dense. They're really good at doing their job. But what if I told you we can make a very similar fuel that is just as energy efficient but it has no bad effects to the environment? And that's right, it's microalgae time. Microalgae are microscopic organisms that live literally everywhere on Earth, even in Antarctica. And they perform photosynthesis just like plants, meaning that they make their own food out of sunlight and carbon dioxide. And that means that they're sucking in carbon dioxide that cleans up the atmosphere. And with microalgae, we can make products that are carbon neutral, which means that they take out from the atmosphere as much carbon dioxide as they put in. And we can make fuel out of that. And a process for doing so looks something like this. We put a bunch of fuel out into the atmosphere. We burn a bunch of fuel, which produces a bunch of carbon dioxide into the atmosphere. But the same amount of carbon dioxide is then sucked in by the microalgae to produce entirely new fuel that can get reburnt and restart the cycle. But there is one problem in the way. That is photosynthesis. Photosynthesis is the key to this whole operation. It's like the star player on a basketball team. And if the star player isn't fully efficient, then the whole team falls apart. And in this case, photosynthesis isn't fully efficient quite yet. And that's dragging the whole process down. Specifically, it's because of an enzyme called rubisco. When photosynthesis starts up, rubisco is still asleep, kind of like you right before you're about to get up for work. And that means that photosynthesis isn't running at its full efficiency until rubisco wakes up. So we have to introduce rubisco to a different enzyme called rubisco activase, which is like your alarm clock. When the alarm clock goes off, when rubisco comes into contact with the rubisco activase, it wakes up and photosynthesis goes back to normal. But sometimes there isn't enough rubisco activase to go around. So in order to keep photosynthesis at its full efficiency and have rubisco running, we need a whole lot more alarm clocks. And that means a whole lot more rubisco activase. And the best way to get more rubisco activase is to use a very, very cool emerging technology called gene editing to manipulate the DNA of microalgae so that they have more rubisco activase. And to do that, we use something called CRISPR-Cas9. Cas9 is a protein that evolved as part of the defense mechanism of some bacteria that essentially is able to make cuts to the very DNA of organisms. And in order to overexpress rubisco activase, the gene that we need, we use something called homologous recombination. And you can think of this as doing some arts and crafts with a piece of paper. First, you take the piece of paper and cut it in half. And then you separate those two pieces, throw in another piece of paper, and tape it all up. And that's essentially what homologous recombination does. CRISPR-Cas9 goes, cuts the DNA, then we insert some new DNA into there that will overexpress rubisco activase, and after all the DNA dust is settled, rubisco activase is overexpressed, photosynthesis is faster, and we have more fuel. So let me ask you, do you think this little green speck can solve the climate crisis? Now you know that it can. With the power of gene editing, we can turn this microalgae into a fuel-producing powerhouse that can power the future for the years to come. Thank you.